The people leading the Vermont Bioenergy Initiative are forging the connection between diversified agriculture and renewable energy production. These farmers, scientists, and entrepreneurs are at the forefront of a local production for local use movement, and they are proving that local food systems and clean energy production together are economical, compatible, and essential. These are their stories.
So I'm John Williamson. We're here at State Line Farm in West Shaftesbury, Vermont. We're in our bio barn here where we make biodiesel. We started a biofuels business 7 years ago now, growing oil crops and turning them into biodiesel. We designed a few features into the structure to make our biodiesel operation a little more efficient and a little safer. Some of the things we incorporated into this building are some solar heating. We put a lot of glass on the south side of the building to take advantage of solar gain, and we installed some hot water solar for some of our process heating needs to reduce some of our energy inputs. We have an oil mill. The mill that we have is a Swedish-made mill. It's a tabby oil press. Biodiesel reacting equipment is all homemade, but it's made out of stainless steel. It's all hard plumbed, pressure rated. This tank here is our main reactor tank. It's a pressure rated tank, meaning it'll hold vacuum or pressure. Also is water jacketed, and we can circulate the hot water from our solar system around the tank to heat the oil up to processing temp, which is around 130 degrees. It's a 1,500 liter tank. Everything is calibrated in liters. It just makes the math easier when we do our processing. To load this tank, we draw a vacuum down on it and just open a valve, and it sucks the oil from our storage tank into this reacting tank. Once the reactor is loaded, then we do a titration. That gives us a recipe of how much lye and alcohol to add to the batch to produce the biodiesel. All right, so a little bit of alcohol. I found it's best to put the caps back on everything. Saves on spills. I use Dixie cups. A little magnetic stir. Phenolphthalein. 5 drops. So this is a sample of oil. There's 1 milliliter. This is lye water solution. I always start out with 10 milliliters. I add these a milliliter at a time when they look for a reaction and when it changes color. So this usually reacts as a pink. So that's at about 2.5. It means we're going to add 2.5 grams of lye per liter of oil. It's always a good idea to write this stuff down. At every titration, you write it down. Because after you do 2 or 3, you're like, what was the first one? You can't remember. In this tank here, we mix the lye and the alcohol together. And usually the volume of alcohol is about 20% of the batch of oil. So it's generally around 50 gallons. So this tank is charged with vacuum, and then we draw the alcohol in by simply putting a hose into our barrel of methanol and drawing the alcohol in. And this is all grounded prior to opening the drum. Once the alcohol is loaded, then we put in the lye, which is either potassium or sodium hydroxide. So we need to measure out that amount of lye that we need. So you have to take some precaution handling lye. You should have all your protective equipment on it. So we're drawing alcohol off the side, through the pump, back in the top into a Venturi nozzle, and what that does is it mixes all that lye up that was laying on the bottom of the tank, and then the second 5 minutes, we mix for 10 minutes, I'll open the bottom of the valve. So at this point, we would probably want to check the temperature of the oil, make sure we're at reacting temperature and not above it. It's real important that the oil be at the right temperature for reacting. Once the alcohol is mixed, then we do a transfer. We transfer from this tank and back into the reactor tank. Open this one. So now we're taking it out of the alcohol mix tank, epoxide mix, and adding it into the reacting tank on top of the oil. So this sequence takes about 45 minutes of mixing. Some of the mixing occurs in the pump. There's a lot of turbulence, high shearing action, so when the oil alcohol mix goes through that pump, it gets churned together, and quite a bit of reacting takes place there. And then also inside the tank, there's a nozzle that creates a lot of mixing action within the vessel. So we're just going to draw off a little sample here. Let's always pull a sample just to make sure before we take it out of the reactor and put it into the settling that we've got a reaction that looks, in the parameters of normal. So, I mean, at this point, if it didn't look normal, then maybe we could, go back to titration or see, maybe test for contaminants or water or something before we finished with it. But this batch looks typically normal. I'd say we got a batch ready to transfer. Next step would be to slow the pump down to transfer speed. So instead of sending the fuel back into the tank, we're gonna send it over into the cone tank, make sure all valves are closed and the tank's vented. So once the fuel is reacted, we then transfer it into the cone tank, and the cone tank is to help facilitate the separation of the glycerin, and this is just a 1 liter example of what's going on in the tanks, but once that reaction occurs, you'll get the glycerin will participate out to the bottom of the tank. So we use a cone tank to help us draw off the glycerin. Once the fuel is reacted, we're going to pump it through these 2 ion exchange columns. This is an upflow column, so meaning the fuel comes through this variable speed pump, flows up through that material, then crosses over. And this is a pure light column. They're ion exchange beads. This column is full of those. And the fuel is pumped down through, and from there it returns back into this tank. And we can turn it on. To control it, we watch this little flow meter, and then we have all these pressure gauges. We can watch and monitor the pressure building in the filtering tanks. And then from there, we can meter the fuel into a customer's tank.
This is biodiesel. This is biodiesel. This is biodiesel. This is biodiesel.